Find the values of x and y. Okay, so we have these triangles, this one and this one over here, and we're trying to figure out x and y. Let's start with x here. Okay, so notice that we have this angle is the same as this angle. They're marked. That means they're equal. And then we also know this angle is equal to that angle. Why? Because they're diagonally across from each other. They call those vertical angles. Those have to be equal too. Angles diagonally across from each other. So that gives us two angles in one triangle the same as two angles in the other. Well, remember, every triangle holds 180 degrees. So if you know you have two angles the same in two triangles, the third angle must be the same because there's the same amount left over for the third angle. So then we know by AAA they are similar. So these two triangles are similar, meaning they're the same shape, different sizes. Right? One's the one on the right is clearly a bigger triangle than the one on the left, but they are the same shape, just different sizes. Okay, now, well here, let me put those marks back in there. Those are actually helpful. Okay, so now, how do we figure, so when they're similar, when we know they're similar, that means their sides follow a ratio. Right? I can match their sides up. So let's start with x. X over 18 is got to equal what? Should I go 24 over 32? Like that? Is that going to be right? No. How do you know? X has to go with the 32. How do I know? Because notice x is the side between what? Look what he's between. Whoops, that is not what I meant to do. Let me go back there. Between the double angle and the no angle. Just like 32 is between the double angle and the no angle. Do you see that? X and 32 have to go together. So I've got to put this 32 on the top. X has to go where 32 goes. And the 18, that's going to go with the 24. Do you see that? See how the 24 is between the double and the single, and the 18 is between the marks of the double and the single. So that goes with the 24. So you got to be careful on the order in which you match these things up. The 18 goes with the 24 in the same spot as the 24, and the x with the 32. Got to be careful. Now, how do we solve this equation when we have two equal fractions? We go diagonal, right? 24 times x is 18 times 32. Use your calculator. 18 times 32. I'm getting 576. All right, and last step, divide by 24. And x will equal 24. So x must be 24. Now, let's try to find y. So now we know x is 24. Now we can try to find y. How about we go y is to 32 as, right? Similar triangles have sides in equal ratios. So the y in the triangle on the right matches up with the 9, right? Because he's between the single mark and the no mark. Single mark and the no mark. So y matches with the 9. 32, between the double and the no mark, the double and the no, he goes with the 24. Doesn't he? All right, let's solve it. Diagonal, diagonal. 24 times y is 9 times 32. Use your calculator. I'm using mine. 9 times 32, 288. All right, divide by the 24. Boom. Y equals, it's coming out 12. Y must be 12 on that one. So there we go. So the moral of the story here is to be really careful how you match up which sides with which sides. Use the marks between the angles, right? The 18 and the 24 go together again because they're both between the single and the double mark, the single and the double mark, etc. So be careful when you set this up. These triangles are similar, so their sides are in equal ratios, but you got to be careful which sides match up with which sides.